Hey guys, welcome back. Behind me is a 2019 Chevy Silverado, 2500 I believe. It's got 8 lug wheels anyways. Customer complaint is the parking aid malfunction light comes on, or the warning message on the instrument cluster. Because it's a newer truck, I kind of want to use the factory scan tool, and I'm going to use the Launch J box with that scan tool. I haven't tested this out with GDS2, so I figured it'd make a good opportunity and a good video to test it with that. This interface comes with the Launch Torque Link, and this is the Smartlink interface. So this is the VCI for the tablet, but you can also use it as a J-box. So we're going to jump inside the truck. I got my laptop in there. We'll plug this into the vehicle. We'll get GDS2 opened up. We'll do a full system scan and see what fault codes we have. Go ahead and plug that in. We'll grab the USB cord and plug this in to the bottom of here. We'll turn our key on. And we'll plug our cord into the laptop. Now I do have a battery maintainer on this vehicle just to keep it from going dead. It started kind of slow out in the parking lot, and it looks like one of the batteries is leaking quite a bit of acid, and they're original batteries. So to prevent that from, causing issues, I just put a battery maintainer on. So as long as you have a valid subscription to GDS2 and you've used TechLine Connect recently, then you can do this offline so we don't have to log in. So I'm just going to open up TechLine Connect and we'll start an offline session. So here in GDS2, I still have 180 days of my software lease before it kicks me out and I have to log back in. This is probably how many days I have active on my account still. So we're going to go to Diagnostics. It's going to ask us which interface we're using. So we're going to go to Launch J2534, Continue. It's connecting to the device, and now it's going to try to identify the vehicle. Click on GDS2 again. There we go. So we have 2019 Chevy Silverado. Hit Next. I want to do a full system scan on this vehicle, so I'm going to go to Vehicle Diagnostics, and we'll just do the Vehicle DTC, Diagnostic Trouble Code Information. And it's going to try to communicate with all of the modules on the vehicle and get a full code scan from each module. It'll tell me which vehicle modules didn't communicate, which ones have fault codes, and which ones don't. Now that we have our full code scan done, we can either click on Details or create the report. I like to create the report. I can save it for later or print it off for our records. It has the date, time, the VIN number, vehicle information, which modules were scanned, which ones had faults, and down here we have our complete code list. So we have control module power circuit, control module power circuit. That's probably from the low battery, which I noticed when I cranked it up outside. Engine control module, we have glow plug 4. More power codes, more powering codes, and then parking assist, we have a low power, low voltage code, and then we have parking assist, front sensor, left corner circuit. And based off of this 22 here, that is our symptom byte. It says too low or too short, low time. Doesn't really make sense, but we'll look this up in service information. So we have a B0954. Let's jump over to service information and see what we can find for that code. Now I'm going to look this up in Direct Hit or Identifix, just because I'm not familiar with that code, and sometimes they'll give you alternate testing to the OEM manufacturer testing. So our code is the B0954, and I don't know if we'll need this symptom byte, the 22. Sometimes it doesn't search for it. It only searches for the primary code. So we're going to search for that, and then we'll look in the information and see what else it has for that symptom byte 22. So I don't see any service bulletins. I don't see any direct hit archives, nothing here except for OEM troubleshooting manuals. We have diagnostic trouble code troubleshooting, and we have the code. Now there's 4 codes listed here. They're probably for the front sensors, all 4 of them. We'll just click on that and it's going to break it down to us what each one of those codes mean. So we actually have that code in several different places, but you'll notice that the last 2 digits don't match what we had. So 02 is a short to ground, 04 is an open or high resistance, and 01 is short to voltage, and 22 is a signal performance. So we have a signal, but it doesn't really like the signal. It says there's something wrong with that signal. So let's scroll down until we find that code again. So here we are, the 9054. Let me zoom in for you guys. So the parking assist control module determines that there is no change in the position of an object while the vehicle is in motion. So that parking sensor is seeing an object, but that object is moving at the same speed as the vehicle. It doesn't move at all. Now we don't have codes for the other ones, so I don't think it was anything weird like a bicycle mounted on the front of the vehicle. I've seen that cause weird codes. Stuff on the back, bicycles, trailers, that'll set weird codes. I don't see anything like that, and we only have a code for the one sensor. So we'll scroll down and see what the diagnostic testing is for that code. And then we can probably go in with the factory scan tool, see if we have any data for those front sensors, and then we can try to test them. So we do not have the 1405. So we're going to go down. We have the 905422. Okay, if it's set, then make sure that there's nothing on them. The truck looks clean. It looks like it just went through the car wash. So that's not an issue. And then it says refer to circuit testing. So they want us to jump straight into circuit testing from this. I just scrolled back up so I can see what the circuit and system description is. I kind of skipped over that part. The sensors are a 3-wire ultrasonic sensor that are used to determine the distance between a vehicle and the object. So it's sending out an ultrasonic signal, it bounces off the object, comes back. Depending on that time delay, it can identify how far away that object is. And a lot of the newer vehicles will give you kind of like a surround view on the radio or on the dash to kind of show you how far away objects are. Now, seeing that this is an ultrasonic sensor, I kind of want to try my ultrasonic leak detector. We bought it early this summer for finding leaks in air conditioning systems, but it's an ultrasonic microphone. And I wonder if that will help us identify the issue with this vehicle, or at least test the sensor. Are we getting an output? Does it sound the same as the other ones? Does it have the same range as the other ones? And then I think I have an ultrasonic pickup that I got from Picoscope. So we could probably plug that in and see what the waveform looks like on a lab scope. I think we'll do that before we get heavy into the circuit testing, just to see if we have a signal. Typically you have a common power and ground going to the bumper. It splits out to all 4 of the sensors, and then they each have their own return signal. And I'm not sure if it'll give us a wiring diagram for it, just so we can confirm that we're on the same page. Because if we had a power issue somewhere else on the vehicle before that connector on the bumper, then it would probably affect all of the sensors. And that's exactly what it looks like here. We have our connector here. This is probably at the bumper. We have another connector somewhere else on the vehicle. But our power split, we have 12 volts coming from the park assist control module. That doesn't break out. That doesn't splice out to all 4 sensors until it is on the bumper. So there is still a chance of a damaged wire, corrosion in maybe just this one connector causing low power. And then we have our common ground down here, and that goes back to the module as well. So we know that we don't have an issue up here in these connectors for power and ground. Now we could still have a bad signal wire. We could have something going on drawing that signal down, or modifying that signal, or 2 of these sensors tied together. But then again, we would probably have codes for both of them. So I think, based off of that, my next direction is I want to try that ultrasonic microphone. We'll look at the lab scope, look at the signal, And then we may check power and ground. Some of these you have to pull the bumper to get to, so that's not really an easy task for us. We can check the signal wire wherever this bulkhead, this X100 connector is. Normally that's in one corner of the bumper. We could check the signal wire there and compare the known bad to one of the known goods. And just while we're at the laptop, I want to look at data and see if we can see information from those sensors, like how far away an object is, anything like that, anything that would be useful. Some vehicles have that, most vehicles don't, so I'm not getting my hopes up. We're just going to look for the parking aid module, parking assist control module. Go to data display, and we have park assist system data. I don't see it here. So it can detect if an object is attached to the vehicle, and that's probably when it picks up, for multiple sensors, and that object never moves with the vehicle, or it always moves with the vehicle. It just turns on that mode that says, hey, we have something attached here. We're going to ignore that sensor. I don't see what I need there, so we'll click here, and we can change our data list. So under sensor data, we have 3 data PIDs. Power mode is run, battery voltage 13.5 because I have the maintainer on, and park assist sensors are on. Okay, so very non-helpful information there. Under disable history, trailer or attached object, excessive speed in reverse, trailer or other attached object, and sensor disturbance. Excessive speed in reverse. I wonder how fast you have to go to get that to activate. And that's just more disable history for the next one. So we don't have any useful data PIDs to help us diagnose this system. So I'm going to record it with a separate recorder so you guys can hear what I'm hearing here. But what this does is converts high frequencies, ultrasonic frequencies, down to a level where we can hear them. It has some sort of processing inside, and I'll just kind of show you. So we'll see if we have a signal at all. Now, this sensor here is the one that was showing as a fault code, and I'm not hearing anything. And I'm not hearing what I expect to hear from this one either. So sometimes these vehicles won't activate the sensors. The scan tool said they're active, but they won't activate the sensors unless you're in drive or reverse, because that's when it's going to be looking for stuff. So I'm just going to set the parking brake. You don't have to have the vehicle running most of the time. I'm going to put the vehicle in reverse, and we'll see if we have a signal. Okay, immediately I have something we can hear. And I'm not even pointing it at the sensors, I'm just in the front of the vehicle. And those are all ultrasonic frequencies bouncing around this microphone. I think I'm picking up some fan noise from my maintainer. So I'm just going to turn that off for a second. So I'm going to bring you closer. We can hear a signal from both sensors, but the ultrasonic detector is picking up a different loudness on this gauge between the two. So at my current sensitivity level, we're bouncing up to a level 4 with this ultrasonic leak detector. This one is only registering that first bar below the 2. So we have a signal, it's just not nearly as strong. And all 3 of the other sensors are about the same amplitude. It's just this one that's different. So I have two different pickups from Pico, and I don't remember which one did what. And I actually thought I had a blue one as well. So I'm thinking one of these is a microphone, but one of them might be just an ultrasonic pickup, and maybe the other one's an RF pickup for like key fobs and stuff. So I'm just gonna connect both of them. I have no idea what our signal range is gonna be. Connect both of them to the scope, and we'll stick them in front of a parking sensor and see if we get a signal. Okay, so we're actually picking something up on the red one, and that's the one that looks like a little speaker in there, so I'm guessing that this is a microphone. So we can see our waveform from the known good sensor, or at least the one that's not setting a fault code. And if I wiggle this around to try to get our highest amplitude, I'm at 215 millivolts. We can see the oscillations in that signal. This other one isn't even hitting my my trigger level. Interesting. And I am getting nothing over here on this sensor. There we go. There's a signal. That is a terrible signal. So we had 200 and some millivolts on the other one, and we have maybe 10 millivolts on this one. But we still have a signal. I'm pretty sure that we're dealing with just a bad sensor. I may have to pull this bumper to get access to the backside of that sensor to do our voltage testing. But at this point, if I'm going to pull the bumper off, I'm going to have a sensor here at the shop just in case, so I can plug the new sensor in and test it to see if, because if I have good power and ground, I want to make sure that it's not something weird on the signal line, pulling the line down. So I think that kind of proves that we have power to this sensor. It is sending out a signal. We can hear it more clearly with the ultrasonic leak detector, but we can see with the scope that our signal is very, very weak. I suppose we could have low power going to it, but since it has active circuitry inside of it, I'm guessing that if we had low power going to it, the circuitry wouldn't even power up. Now, we can confirm powers and grounds once we pull the bumper off, but I don't think that we're going to get much access to that sensor with the bumper in place. If it was this center sensor, I think we could pull this plastic piece off, but they have some lights mounted, so we do want to make sure when we get in there that their lights, the screws aren't touching the harness anywhere. But I got a feeling this is just a bad sensor. I see some touch-up paint here, so it's possible that this vehicle has been, hit in this area and caused damage to that sensor. We'll wrap it up here for now, unless I come up with something unusual once we get the bumper cover off. But in the service information, it looked like they give you some voltage readings of what you can check on the harness side and what is good and what's not good. I personally like to see a waveform. So if I was going to check voltage, I'm going to check for a lobscope pattern. And we kind of got that pattern from sticking that ultrasonic pickup in front of the parking aid sensors. So let me know what alternative testing methods you guys have developed for parking aid sensors. I think some people have actually made their own sensors. I believe Joe's Auto Electric has some other sensors that he makes for testing these. I don't have one, but I'll put a link to his stuff down below. If you guys have any questions or comments, put those down below as well. I'll try to answer them as quickly as I can. If you enjoyed the video, give it a thumbs up. If you want to see more videos like this, subscribe, click the bell. Thanks for watching, and I'll see you next time. So a little bonus footage. Before I called the customer to get approval on that, I want to go back and revisit that glow plug code that we had. Now, I really like when Chevrolets come in with a glow plug code because they're very easy to diagnose. So we had a glow plug code for cylinder 4 learned value offset or something like that. We're just going to go to the glow plug control module, and if we go into data for the glow plug control module, it'll actually give us the resistance and the amperage for each one of these glow plugs. Now that could mean that there's a circuit issue or a connection issue, but even on a good vehicle that doesn't have any fault codes, maybe on a pre-winter checkup for a customer, you can go in with a factory scan tool or an aftermarket scan tool. They all show this data. Go into that glow plug control module and look and see if the amperage is the same across all of them. Now I give them about 1.5 amps of difference before I say that, okay, it needs glow plugs. We have some that are starting to fail. So if we look right down here, we have cylinder 1 pulled 16 amps, 2 pulled 14.5, 3 17.5, number 4 9.5. So that's a huge difference between our highest and lowest already. You know, we're 8 amps of difference. So that could be why number 4 was setting a fault code. 12 amps, 14.5, 14.5, 10 amps. So we have 10 and 9.5. Those are both drastically lower than all the other ones. On average, I would say that I see these glow plugs around 15 amps. But these I'm definitely going to call bad glow plugs. I'm going to recommend all of them. There is a risk involved. Some of these trucks, especially the newer ones, the glow plug will break or swell on the end, and they'll get stuck in the head, or the end of them will actually break off. So it's better to change them earlier than later, and hopefully we don't have an issue. And then I take them out very gingerly to try and feel if I have any breakage. And then if we wanted to look at the resistance, which this just basically calculates one number off another one. I don't know if it's actually measuring amperage or if it's measuring resistance. More than likely it's measuring voltage drop across a shunt inside the glow plug control module as it activates each one of these, and it knows that that voltage drop equals a certain resistance or amperage for that glow plug. So our resistance, we have 0.83 ohms, 0.9 ohms, 0.73, 1.4 ohms, 1.1, 0.9, 0.9, and 1.3. So it gives us that information. We can easily go and look up service information, find out what normal is, find out what our range is, and make a judgment call. But because this has a code for glow plug and I see a drastic change in our amperage, I know that we have a faulty glow plug.